Welcome back. Today we're going to look at section 1.6, which is limits that are involving infinity. Okay. All right, so the first thing that I need to make clear is that up until this section, so when you work in sections 1.3, 1.4, and 1.5, okay, and this should say section 1.3, so a little typo there, okay. So back from section 1.3, when we did the direct substitution, okay, go back to thinking about that. When we did direct substitution, if we got 0 over 0, we knew that was indeterminate form and we looked for an answer. If we got a number over 0, okay, we said that the limit did not exist. That was because the limit values went either to positive or negative infinity, and according to the book, a limit value had to be numerical. So we said it did not exist, okay? Now, from section 1.6 on, we're going to be more descriptive. So if we end up with the form of a number divided by 0, okay, which is not indeterminate, but if you end up with a number divided by 0, then that's telling you you're at an asymptote, and that means the values might go to infinity, might go to negative infinity, or still might not be, or still may not exist. Okay, so to be more descriptive in our answers, we're now going to allow an answer of infinity or negative infinity. So that's what this section is about, just to make sure you understand the difference in that. And then we're going to look at also what happens as the limit of a function as x approaches infinity. Okay, that's an end behavior, a part of the graph, and we're going to look at those answers as well today. All right, so keep that in mind because some of you are still working on, I don't know when you're watching this video. So if you're not done with web work section 1.4, 1.3 or 1.4, then those answers will still be does not exist in WebWorks. But when you get to section 1.6 in WebWorks, then you're going to start using infinity, okay? So I know it's a little bit confusing, but that's the way the textbook kind of introduces you into this more descriptive kind of answer. So just keep that in mind when you're working in WebWorks. After you finish section 1.4, then everything will be the same from here on out. We're going to be more descriptive. All right, so Dr. Taylor did numbers 1 and 2 with you, kind of going through and explaining the difference. So I'm just going to throw this up real quick just to kind of remind you. So now we're going to look at what happens as a limit approaches an asymptote, right, where we ended up with a number divided by 0 when we did our direct substitution. So either the left side and the right side are going to both go to positive infinity. If both the left and the right side go to the same infinity, then that can be your answer now. Both sides may go to negative infinity. That answer would be negative infinity. And then the second one he did with you, the left side went down and the right side went up. So this one still would have an answer of does not exist, okay? So all we're doing is changing the limit answer to either positive infinity if both sides are heading up. We would have an answer of negative infinity if both sides head down. And you still could possibly have a limit answer of does not exist if one side of the asymptote goes down and the other side goes up. Okay, so I know he did those with you, went over the chart and all of those things. So I just want to make sure that we're okay with what we're getting ready to do now with our answers. Okay, so make sure that you also fix that if that's, I can't remember if they've updated that in the new notes or not, but that should be from 1.3. Okay, moving on. All right, so since we're now looking at asymptotes, okay, we're going to just do a quick review of how you find asymptotes algebraically. We did this in Algebra 2 probably. We did it in, if you had Math 1103 or Math 1100, we do this in all of those classes. So hopefully you guys remember how to find asymptotes. All right, so you have what we call vertical asymptotes, and we have horizontal asymptotes. So vertical asymptotes are when you have x approaching a. Okay, you're actually approaching a numerical value on your limit problem. And when you check, the direct substitution, you would get a number divided by 0. I'll write that on direct substitution. Okay. All right, so remember, on direct sub, you always start by plugging in a number. Don't forget that. So when you're doing a limit and you plug in the number and you got 0 over 0, those are the ones from section 1.3 and 1.4 where you do factoring or simplifying, conjugate, right? If you do direct substitution and you get a number over 0, again, back in sections 1.4, that would have been no solution, does not exist. Now we're going to go and be a little more descriptive on that. So these are what we call vertical asymptotes. And to find a vertical asymptote, okay, remember how to do this. Vertical asymptotes come from a rational function. You have to factor both the numerator and the denominator, and then you're going to look for the non-common factors that are in the denominator, in Q of x. Those are going to be your vertical asymptotes. If you have a common factor to the numerator and denominator, that's not an asymptote. If you remember, those are called holes. So we're just looking for vertical asymptotes. So those are the ones that have no common factors. Okay? All right, those are vertical asymptotes, up and down. Now, we also have horizontal asymptotes that go side to side. Those are called your end behaviors. That's what's happening at the end of the graph, okay? So that will be problems where you see x approaching, and it could be positive or negative infinity, okay? So that's different. Vertical asymptotes are when x approaches a number. Horizontal asymptotes in your limit problems are going to be x approaching infinity, okay? So a lot different. So you got to pay attention to the problems. Okay, so if you remember how to find horizontal asymptotes, you're looking at the degree of your numerator and the degree of the denominator. So if the degree in the denominator is bigger than the degree in the top, then your horizontal asymptote is always y equals 0. If the degrees in the top and the bottom are equal, then remember you take the ratio of the leading coefficients. Okay, we'll go over this in just a minute. And then if the degree in the top is bigger, then there is no horizontal asymptote. There would be what we call a slant asymptote. Okay? And if you have a slant asymptote, that means the end behavior would be going to plus infinity or negative infinity. Okay? If you have a horizontal asymptote, that means your limit or your end behavior would be going to a number value, right? Wherever that number is going to be. So this is trying to help us figure out these limit problems, okay? So a lot of old information, but for new stuff that we're looking at now. All right, so real quick, we're going to do these 4 problems. They're just asking us for find the vertical and horizontal asymptotes. So for vertical asymptotes, you want the problems factored. So I'm going to go through and do the vertical asymptotes first. Let's just knock that out. All right, so number 3 is already factored. Right? We can't do anything with that one, so we are factored. Number 4 would be x plus 8 over x plus 8, x plus x minus 8, difference of squares. Okay, so I'm just factoring right now. Number 5 is factored. Can't do anything with number 5. And number 6, I'm going to rearrange the bottom so that it's in the right order first, and then I'll factor. So this is x squared minus 3x plus 2 in the bottom, right? I put it in descending order. And so now I can factor an x out of the top. Leaves me x minus 2. And the bottom factors 2 binomials, x minus 2, x minus 1. Okay? All right, so I factored everything. So now I can go back and work my vertical asymptotes. All right, so remember, vertical asymptotes what makes the denominator equal 0? That's not a common factor, okay? All right, so for number 3, to find out what makes the denominator equal to 0, I would set that equal to 0 and solve it. Okay, hopefully if you look at that, you'll know there's no solution to that because this is a positive number and so is that. But let's say we were just doing what we were told. We set the denominator equal to 0. We move the 1 over, get -1, divide by 4, -1/4. Take the square root of both sides, and hopefully somewhere along the way you're going to say, I can't do that. There's no way that I can take the square root of a negative number. That's an imaginary number. We're not using them. These are all real number answers. So this has no solution. So the vertical asymptote would not exist. Okay, so this one doesn't have a vertical asymptote because it would be this number. We didn't get that number. All right, over here I have a common factor. So that's a whole, that's not an asymptote. So my only asymptote would come from what makes x minus 8 equal to 0, and that would be x equals 8. So your vertical asymptote for number 4 is x equals 8. And remember, these are lines, so it has to be x equals. You can't tell me the vertical asymptote is 8. It has to be x equals 8. That's how I know it's a vertical line. All right, for number 5, no common factor. So to find the vertical asymptote, I would set 5x minus 2 equal to 0. I would solve that. So 5x equals 2. X is 2/5. So there's my vertical asymptote. X equals 2/5. Okay. So those are my vertical asymptotes. All right, and over here, I have a common factor. So that's a whole. So my only vertical asymptote would be where x minus 1 equals 0. So that would be x equals 1. So your vertical asymptote here is x equals 1. Okay, so remember, that's just a quick overview. That's how we found vertical asymptotes. Now, to find horizontal asymptotes, we're just looking at the degree of the problem. Okay, so horizontal asymptote for number 3. Okay, look at your degrees. They are the same, x squared, x squared. So if it's an equal degree problem, you take the ratio of the leading coefficients, and it's y equals, so we'd have 16 over 4. And then we would reduce that, so y equals 4 is your horizontal asymptote. Okay? All right, look at number 4. We need the degrees. The degree in the top is 1, x to the first. The degree in the bottom is 2, x squared. If the degree in the bottom is bigger, then the horizontal asymptote is always y equals 0. No question about it, when the degree in the bottom is bigger. All right, number 5. Degree in the top is 3. The degree in the bottom is 1. So according to the rules up here, that means we have no horizontal asymptote. We would have a slant asymptote. But this problem just asked us for the horizontal. So in this one, it would be none. Okay? No horizontal when the degree in the top is bigger. All right, lastly, make sure you're looking at the highest degree. That's why I put them in order. So degree in the top is x squared. The degree in the bottom is x squared. So the horizontal asymptote, again, if the degrees are the same, you're taking the coefficients out front of those terms. So that would be y equals 1 over 1, which would be y equals 1. Okay, so your horizontal asymptote would be y equals 1. So again, that's a quick overview, but you guys should know how to do that and hopefully remember how to do that. But these are going to help us to do these limit problems that we're working on today. Okay? All right. So let's look at vertical asymptotes. Okay. So vertical asymptotes occur when the limit as x approaches a from the left of the function goes to positive and negative infinity, or the limit from the right of a goes to plus or minus infinity. Okay, so remember what I told you. This is the direct substitution. So this is when you plug in a and you end up with this kind of a scenario. Okay, so if you end up with this kind of a scenario, We used to say does not exist. Now we're going to have one of three choices. It could be does not exist, but it could also be positive infinity, and it could also be negative infinity. These are your only three choices when this is what you get with direct substitution. Okay? So before it was just this, now we're going to be more descriptive, right? We're going to be able to tell which way we're going. All right, so Dr. Taylor did number 7 with you, but just to remind you, okay, he plugged in 2 to start with, and when he plugged in 2 for direct substitution, he got 5 over 0. So that meant now that we're in section 1.6, we can't just write down does not exist for the limit. Okay, we needed to look at what happens on the left side of 2, what happens on the right side of 2, and then if both sides go to positive infinity or both sides went to negative infinity, then that would have been our answer. Okay, so he did the work with you. Both sides went to positive infinity, so that's why he ended up with this answer and not D and E. Okay, so if you didn't do his work, but that's kind of what he goes through with you. All right, then he also did number 8 with you, which again, on the new form, I think it's filled out, but I don't know if you guys are looking on the notes. This was just a typo. The limit should go to as x approaches -4, not +4. And then this one should be -4 to the left from the left. This should be the limit as x goes to -4 from the right, and then the limit as x goes to -4. So depending on what version of the notes you have in front of you, that was just a typo. I'm pretty sure it's fixed on the new notes, but I just want to mention that. Okay. All right. So he does this one with you again. And this side, remember, when he did it with you, went to positive infinity. This one went to negative infinity. So there was no limit still. Okay. And remember, if we plugged in the direct substitution on this one, we ended up with, if you plugged in -4, you got 2 over 0, right, for the direct substitution. So that means one of your answers is going to exist. But since the left and the right side went to different places, then that was still the answer for that problem. Okay? So I hope that's making sense to you, but it's real important to do direct substitution. I can't stress that enough, because that's really going to tell you what kind of answers you're looking for. Okay? So if that's still not making sense to you, again, get some help, let me know, because that's hugely important for limits. Okay, number 10, I will do with you. We got the limit as x approaches 2 of x plus 1 over 2x minus 4. So again, if I'm doing this problem, I don't know if this goes to infinity or if I get a number answer. So I always have to do direct substitution. So if I plug in 2, I get 2 plus 1 over 2 times 2 minus 4. Well, that gives me 3 over 0. So what that tells me is I know that my answer's got to be D and E, infinity, or negative infinity. Remember, if I got 0 over 0, that means I'm going to get a numerical answer. That means I could factor or do something. But I don't, some of you might look at this and say, oh, well, I can factor the bottom. Well, I don't need to do that if I know that that's not a problem that is factorable. Okay. So these are my choices for my answers here. Now, I want to show you something, because I know Dr. Taylor talked about this some, but, these kind of problems are typically done without a calculator. Okay. Now, in this semester, because, we don't have you coming into the final exam where we can give you the non-calculator part, I know that you have your calculators in your hand, and yeah, that's helpful, but I still want you to understand how it is that you can find the answer without your calculator. And it's not a hard process, but let's look at that a little bit careful with these, okay? All right, so I need to look at the limit as x approaches 2 from the left of this problem. And I need to look at the limit as x approaches 2 from the right. All right. So, first thing I want to do is look at the calculator to kind of explain this to you before we actually do it, because I think it kind of makes sense. So I already went in, I believe, and in my y equals, I put in the problem. So remember when you're doing this, either the new calculators, you've got the fraction form, which is fine, but if you have the older version, please make sure you put parentheses around the numerator and the denominator. If you have it already set up as a fraction, then you don't need to worry about that. All right, so if I look at the graph, okay, I can see that as we approach 2 from the left, it's going to negative infinity, and as I approach 2 from the right, I'm going to positive infinity. Okay, so let me just jot that down here. So 2 is my asymptote. So I know I'm doing this and I'm doing this, right? So I can see that the answer is going to be D and E. I know that before, so the calculator obviously will help you immensely with these. But if you don't have a calculator in your hand, how do you know? All right, so let's go to the table and let's put in numbers that are approaching 2 from the left, okay? If we're approaching 2 from the left, that's numbers smaller than 2. So I'm going to start with 1. I always start with a whole number, the first whole number that's to the left of this number, okay? Now, that's not really close to 2, so now we want to get closer to 2. So 1.5, 1.9, right? This is typically, if we had our calculator, we'd be doing a lot of 1.9s, right? So you can see the closer I get to 2, I'm going closer and closer to negative, really big negative numbers, right? Which is negative infinity. All right, so what I tell students to do, so you don't have a calculator, you don't even have to use it. Pick the first whole number. Don't use decimals because we're going to do this without a calculator. Pick the first whole number that is coming in from the left of 2, which would be 1, right? So I'm going to use 1. Okay? Use 1. So I'm going to plug 1 in here. So that would be 1 plus 1 over 2 times 1 minus 4. And I end up with 2 over 2 minus 4, which is negative 2. I end up with a negative number. I'm not even going to write what it is. Any number that I use that's coming from 2 from the left, all I care about is the sign. Because the closer and closer I get to 2 from the left, they're still going to be negative numbers. It's just telling you that this is where we're going. So this just means we're going to negative infinity, right? We were. If I'm doing this by hand, I don't want to pick the decimals. And I need the decimals to see how close I'm getting. But again, to do this, and I know I'm only going to get one of these answers, so when you end up with a negative answer, that just means that side of the graph is going to go towards negative infinity. So on this side, as x approaches 2 from the right, what's the closest whole number to 2 on the right-hand side? That would be 3. So if I plug 3 in here, right, I end up with 4 over 6 minus 4 is 2. I end up with a positive number. And remember, that's all I care about. That means I'm going to positive infinity. And that's exactly what's happening, okay? So I want you to understand, yeah, you have your calculator, that can help you, but, if and when you ever get back to the classroom and you can't have a calculator in your hand, you need to understand this because it's not a hard process, okay? So that's how I know that number 9 is a D&E problem, okay? Using it by hand. I didn't even need the table. I don't need the table. I just need to know the sign of any number that's on that side of 2, okay? So hopefully that makes sense. I know I spend a little more time on that one, but that's kind of important that you understand that. Okay. All right, so now we're going to look at end behaviors. Okay, end behaviors, part D, limits as infinity. So now, this is the first time we're looking at what happens at the ends of the graph. So either the limit as x approaches positive infinity or x approaches negative infinity. Okay? So you go back to this problem I just graphed here. This is what we're looking for. As x goes to negative infinity, what number am I going to? And as x goes to positive infinity, so those are the end behaviors. Okay, that's different than when x goes to a number. When x goes to a number, that's a vertical That's up and down on the graph. Okay? All right. So again, all these little things, but you got to understand because that's helping you decide what it is that you have to do in the problem. Okay? All right, so it says, as a limit as the domain approaches infinity, limit of x approaches infinity of f of x. So that's what we're looking at. That's the notation. Okay? Now, I'm going to give you another identity up here, which I think is real important for before what we go into. I wish it was here, but it is not. This is an identity in calculus. Okay? The limit as x approaches infinity of 1 over x equals 0. It's a huge thing what you're getting ready to do right now. So let's make sure you understand this, okay? If you plug in numbers for x and get closer and closer to infinity, 1 over that will be getting closer to 0, okay? So let's think about that. You've got 1 over 10, 1 over 100, 1 over 1,000, right? 1 over 10,000. If you compute those, this is 0.1, 0.01, 0.001, right? So as the denominator of a fraction gets really big, the fraction goes to 0. Right? So the bigger the denominator in a fraction, when it's in the denominator, any number divided by a huge number is going to be smaller and smaller and smaller. So this is an identity, and this is what we need to use kind of moving forward, because that's what this whole process of finding these limits is about. All right, so Dr. Taylor, I know, did this with you, okay? So to find the limit as x goes to infinity, okay, this is doing this algebraically, you're going to determine the degree of the denominator, and then you multiply both the numerator and the denominator by 1 over x to that power, whatever that degree was. And then you clean up, you distribute, and then you can find the limit. So I just want to remind you what he did for number 10, and then we will look at 11 and 12. Okay? So we took this, we looked at the problem. So first off, I'm doing x approaches infinity. So then I know in order to do the algebra on this, I need the highest power, the degree in the denominator, not the numerator. What is the highest degree in the denominator? Which was x squared. So we're going to multiply every term everywhere by 1 over that, 1 over x squared, that highest power. So then you distribute, and he did that with you, okay? So 6x squared times 1 over x squared, the x squares canceled out. Here we have 1x canceled out, so we had 2 over x, right? So you're just distributing and multiplying everything by that. Now, this is where this comes in. Any term that is still got x in the bottom is going to go to 0 based on this, right? Because we're still going to infinity. So if we put a really big number in here, that term goes to 0. You put a really big number in here, this term goes. So you're looking, any term that still has a variable in the denominator goes to 0. So you are left with the limit as x goes to infinity of 6 over 2 in this case. So he got the value of 3. Okay? So that's the algebraic way to find the limit as x goes to infinity. Seems pretty straightforward. It's not hard. Okay? There's a few harder ones on the pages coming, but not extremely hard. It just depends on the polynomial that you have. All right, so look at number 11. What is the highest degree in the denominator? That would be x squared. So we're going to multiply everything in the top by 1 over x squared and everything in the bottom by 1 over x squared. Okay? We're going to distribute that out. So the limit as x goes to infinity. So x cubed divided by x squared is x plus 4x divided by 1 over x squared will give you 4 over x. And then 2 times 1 over x squared, 2 over x squared. And then in the bottom, multiply 6 times 1 over x squared, that gives you that. And then minus 2, and then the x squares are going to cancel out. So again, everything that is going, that's got an x in the bottom goes to 0. So now we're left with the limit as x goes to infinity of x over negative 2. Okay? So this time, when you plug infinity in, you're going to get a big number divided by negative 2. Well, as this gets really, really big, and you divide it by negative 2, you're still going to have a really big number, but it's going to change it to a negative. Right? So that will end up going to negative infinity. I mean, infinity divided by anything is still infinity. It's just changing that to negative because we had that negative sign. Okay. All right, look at number 12. Highest power in the denominator is 2x squared. So we're going to multiply the top by 1 over x squared and the bottom. All right, so that's going to give you the limit as x goes to infinity. Multiply that, we get 2 over x over 2x squared divided times 1 over x squared is just 2. X times 1 over x squared would be 1 over x. And then negative 1 times 1 over x squared is negative 1 over x squared. Everything goes to 0 that has x in the bottom. So now we have the limit as x goes to infinity of what's in the top. Okay, we canceled everything out. So what is in the numerator? That would be 0, right? And then in the bottom you have 2. So we end up with 0. 0 divided by any number is just 0. Okay? All right, so underneath there is kind of putting this together. And I always have students say, do I have to do what you just did? You know, if you're asked to use algebra and show how to find these limits, then yes. But if you remember what's this conclusion, I'm okay with you doing that. You just got to be careful because these are kind of easy because they go to positive infinity. When we go to negative infinity, or you put radicals or different things in a problem, then that changes this up. So you got to be real careful if you're going to do this shortcut. But for these 3 problems here, yeah, the shortcut would work. So this has to go to end behaviors, okay? So remember with end behaviors, don't look at the answers that we have. But if I asked you for what's happening at the end, right, the horizontal asymptote, you would look at the degree, and the degrees, if they are the same, then you take the ratio of the leading coefficients. So in this problem, if I asked you for the horizontal asymptote, it would have been 6 over 2, which is 3. And that's exactly what that limit is, okay? Because that is the end behavior. That's the horizontal asymptote. Okay, on this one, the degree in the top was bigger. And if the degree in the top is bigger, remember that's a slant asymptote, so your answer has to be plus or minus infinity. Notice what we got. You still got to figure that out based on your numbers, okay? Look at this one. The degree in the bottom was bigger. And always when the degree in the bottom is bigger, the end behavior is y equals 0. And that's what we got. So this is just recapping for you that when you're doing a limit as x goes to infinity, you can use your end behavior, your horizontal asymptote rules to help you figure out these answers. What we did here is the algebraic way to do that. Okay? So just make sure, again, what's coming up on the next few pages, you got to be a little more careful than just plugging in and doing that shortcut. Okay, so that you're going to kind of have to be careful with. All right, I'm going to stop the video here and do a part 2. So you can start working on some homework, or if you want to continue with your notes, then just jump over to the part 2 video. Okay, and let me know if you need any help.